welcome. Or welcome back to episode 15 of Whether or Not. StellaQ here, and well, here we all are, smack bang in the days of big deception. And it's certainly bled its way into almost every crack and crevice of the information and communications landscape. There never seems to be a drought from the sensationalism long enough to kill off the population of puppets, pawns and players in power just following orders, or the endless coterie of shills and grifters further smearing toxic mud for a dirty buck, shamelessly perpetuating the structure of confusion and fear at a time when people are in need of a bit of truth and security and yearn for something solid and worthy of trust. But putting those pitiful bottom feeders aside, it has become clearly evident, at least on a more grandiose scale and across all industries, that those who set the whorehouse-style guidelines and those who tightly guard the data library of Alexandria, those self-appointed experts who wag their tails to stakeholders' heavy petting, are prone to a little tweaking and tampering on demand to please their abusive masters who'll throw them a few tasty scraps and then kick them back to the curb to lick their wounds and continue carrying out orders. Big weather is not immune. When it comes to climate change, crisis, warming, forcing, where are we now? I've lost track. The records are looking a little tired. Those outdated old facts are in need of some fervent stretching to tighten up some of those loose statistics and iron out those pesky graph lines and showing all those natural cycles. Inject a little botulism into those hills and valleys to plump up the volume of bombastic bunkum. But the old dog-eared charts are in need of more than just a nip and tuck. No, this requires a full makeover to push, prod and stitch that agenda into shape. Mainstream media cover-up is provided to hide the bruising. It's free of charge, as always. So, here's the point. You're probably familiar with the old adage, if you want something done properly, you've got to do it yourself. This used to have a more practical kind of undercurrent, but we found ourselves in quite a dire situation where we're told to trust the experts while they blind us with their serpentine science, their fluid statistics, shifting goalposts and morphing terminology, relying purely on public shortage of memory, knowledge, time and skills to check their working out. That's a pretty sure bet. It's been designed that way. The mainstream media offers nothing but a programmed script. That's now a known given. And equally, mainstream weather has snuck up on the outside and overtaken the spotlight and the headings regularly, in addition to the more traditional final 5 minutes of the news show that serves to seal the rhetoric of the day with an unprecedented bow. Gee, it's almost like they're trying to wring as much fear as possible out of every situation and bathe in the depths of vulnerable seasons and milk every crisis just to make their topical point. But we have the power to change the odds. Yes, we do. As technology allows the culprits at the wheel to steer the narrative into overdrive, there are equal opportunities to approach from the rear and catch up and ram the plan from behind with the most dangerous and feared weapon on the planet: self-education. It scares the smoking pants off their lying butts, it does. They realise they can't send us all back to sleep, so the next tool out of Pandora's box is distraction. Oh, there goes that squirrel again. We have to return fire by detaching from the nipple of the big brother chest feeders and perform a metaphorical mastectomy. Render big them weak through our own strengths. Self-education. So that's what this is about. It starts with unlocking our own understanding of the language they feel that only they can interpret. Let us amputate them from the equation, disappear the middleman, if you will, because he's not suicidal and he won't be going away anytime soon on his own. So I will claim with confidence that by the end of today's lesson on how to read weather charts, using the same data as big they do, you'll feel empowered enough to get friendly with your inner geek and make your own weather predictions, to make your plans accordingly. Come to your own verdict without the fear blurb attached. So I hope you'll stick around. Let's get skywise. Hello, Jeff. It's good to see you again.
Hi, Stella. It's been a while. Great to be here.
It certainly has, but the skies are still there and weather is still weathering. So what are we going to talk about this time?
We're going to go back to way back in the basics of weather observations to look at weather maps, look at the data acquisition, where it comes from, and the products that we use to see it, so that when you live near an airport, you can access the data from that airport and go, what's that cloud? What's the height of that cloud? And the professional observers have that data. And then you can go, visibilities, so-and-so, you got fog, rain, types of clouds, all that stuff. You can go and look at it and see what the professionals are saying at the airports near your house.
Nice. Yes, it's not exclusive just for the pregnant weather girls, is it? We can all access this data ourselves.
Yep.
And go, oh, all right, good. That sounds like a good plan. So here we go. I'm going to launch into your screen share. Are you ready for this?
Yes.
All right. Launched. It's all
Okay.
yours.
Oh, and I should add too, another reason for this, to see this stuff, is when you get a forecast, you're going to be able to verify it by going to that.
Yes,
product.
Good point. Good point. Because we do need to do that these days, don't we?
Go back to the hurricane season with Milton and with Helene, and we're being told, category 3, category 4, but you look at the data and the data is saying the opposite. It's saying tropical storm strength. It's like, come on, guys, you're 3 levels high. What's the deal with that?
Well, while we're on that subject, it's not exclusive to you guys, because here in Australia, the BOM, which is otherwise known as the Bureau of Meteorology, they're way off as well, and to the point that some of the senators are holding them to account in Parliament, question time and in the Senate. So,
wow.
So therefore, it's a good thing for everybody to learn how to read these things themselves and verify themselves, because they're the same data, isn't it, that they're using, but we don't manipulate it. So, exactly. All right, here we go.
Okay, so weather observations, the codes that go with it, maps and charts and apps. So the data collection network, there are approximately 18,000 places in the world. Each of those green dots, this is showing the Windy app right here. Each of those green dots is a weather observation location. That's in the United States, Canada, down in New Mexico. If you, when we go into the actual apps later, I'll show you how to navigate, stuff like that. You can slide the map to the left, right, up, down, zoom. You can do all the good stuff with your cursor that you can with computers these days. So it's pretty incredible compared to what we did in the old days. In this case, you could see that I have the little airplane icon selected down below in the lower right corner. That's showing that it's the airport data. Right. If I were to click it to the balloon, that's the weather balloon data. There's all this other stuff on here, like webcams and things like that. But the ones that I primarily would use will be the weather balloon for access to the soundings, or looking at the observations, and that's what we're going to talk about today. I was looking at a wave cloud on the satellite over some terrain, over some mountains, and I went to the Windy app and went to webcams, and I saw the darn thing.
Oh, nice. Yeah.
It was wonderful. It was so cool. So this does show the models that are being used. So this has 1, 2, 3, plus 3 more that are not shown in this screenshot, but each of the weather models differs a little bit from the other. So this is talking about the European model. It's using the European model when we go into the any of the parameters that are on the right. And this is obviously not live, so we can't look at those right now, but we will later. And then you have The HRRR or HRRR, which is a high resolution model. The GFS is another long-term model, and there's other ones too. So
can I ask a
you can
question
look
here?
at the differences between them and go, that one's doing better than that one. So I'm going to use that one today to follow the forecast for what's happening today.
Mm-hmm.
So
when you say, excuse me, sorry, when you say models, are you talking about, what do you mean exactly? Is that like different satellites or what?
the computer programs that they're inputting this live data into, like every 12 hours you get the Radiosonde data. That's the basic thing, that's the main thing that that determines the weather, that they plug all that data from all the Radiosonde sites around the world, and then the hourly observations as well get plugged in, and that is the thing that your forecasts are based on.
So all these different models, they're from like, is the first one that's from like Europe, is it?
Yes.
And so they're from different parts of the world.
Yes.
Okay, thank you.
Okay, so page 2. We're going to give you the tools to be able to view and understand the coded weather observations of the professional weather observer. With the airplane mode selected, and I put my cursor over any of those sites, you get this pop-up menu. This is the Kirksville Regional Airport, and it shows the time of the observation. It shows that it's an automatic station. It shows that the wind is out of the northwest from 310 at 5 knots. 10 statute mile visibility, clear skies, temperature 29, dew point 22. That's the altimeter setting, which airport or aircraft need. And then it goes into some of the remarks, and that differs for everywhere. So I'm going to show you some stuff today, but I'm going to show you where to learn to go and read them in depth as well.
Okay.
So I'll give you the references.
So this information comes up when you click on one of those green dots. Is that correct?
That's just hovering over it.
Just hovering. Okay, great.
I'm going to show you what that just pops up. But then when you do this, I want to show you too some of the sites around the world. So there's Australia and the Pacific Islands. There's Europe. You can see there's dots everywhere. Not many in the Amazon. Pretty few and far between. China, Taiwan. Not every one of these sites is actually reporting, but you can find out if they are by hovering over it, which will happen in the real app when we look there.
Yep. All right. Question. You've got the green dots, and then there's also purple and red. What do all the different colors mean? Do you know?
Okay, so like red, that'll tell you the conditions at that place. It's a color code. Like if we go back to the previous screen. No, not the previous. That one right there. VFR. That's visual flight rules, which means that the weather's really good. You don't have to have instrument flight rating as a pilot to take off from that airport or to go to that airport. Whereas if the clouds were at a certain height, like if they're, I forget the rules actually, I think it's below 1,000 feet, it goes to IFR, which means you have to have special ratings as a pilot. So it's just a code, a quick color code to tell you that, up here in the Northeast, you could see that there's some red dots. Those are not good weather, fog, rain, whatever it is. It's just giving you the clue that something's not right there. You have to have special ratings, like down in Italy here. On that day when I took that screenshot, it wasn't good there.
Right. Okay.
So you got these places all over the world, China, down into Africa, and it may be that some of these white ones are just not reporting for that past hour. So we'll explore that as we go through.
Okay, just from the little bit that I've been researching is seems to be a lot of now out of commission type stations where they assess, let's say, they assess because they're no longer actually active. So they just, anyway, that's all about the data manipulation, basically. They assess them because they're not actually in commission anymore for whatever reason, whether they've just gotten out of date or anyway, that might be why.
I saw what you're talking about. There are
Mm.
places that either are not up to snuff as far as their equipment, or the location of the gear doesn't fit the parameters, so they grade the locations.
Yep.
On a kind of like a grading scale. And if you don't meet the real qualifications, now they're going, you need to come up to snuff. You need to get better at for this. I think that's what you're talking about right there.
Yeah. Okay. Some of it's actually about manipulation for the narrative, I believe, because instead of going out and, upgrading some of those things or reconnecting them or whatever it is that is, the said problem, they're just assessing, averaging or whatever.
Okay.
So it's not actually real readings in some of them. But anyway,
Yeah,
that's another show perhaps.
That needs to be called out. Yes. So everything needs to be accurate. You have to meet the standards of the equipment that they tell you. Just as for example, I belong to that network called CocoRAS, which is the precipitation measuring network. And I have to buy the professional rain gauge. You can't just use any rain gauge. If you want to be a part of that network, you have to buy the good one.
Mm-hmm. Good.
Just
Good to
measure
know.
the rain so that it's accurate. So
Yeah.
Anyway, so when I hovered, it showed the pop-up screen. When I clicked on Carson City here, which is whichever state that is, Nevada maybe, I'm thinking possibly, but Mason City Municipal Airport, I stand corrected. It shows you there's a button up there called raw mode. And if I wanted to see the METAR code, which is the code that they use for the weather people across the world, then you have to know the code. And I'm going to give you the references for that so you can, but you can just click the cheat button and it says it in plain language.
Right.
But you still have to know what scattered means. I mean, that type of stuff is also given in those deciphering papers that I'm going to give you. Mm-hmm. So like, for instance, right here, most people are going to be able to figure out that's 330 northwest, 360 due north, 180 from the due south, 11 knots versus miles per hour or kilometers. This is the speed that they use for weather people. Visibility 10 statute miles. Clouds scattered at 11,000 feet above ground level. Temperature 26 Celsius. Dew point 16 Celsius. That's the temperature that you have to cool the air to get a cloud. Altimeter is the measurement of, in this case, inches of Hg, which is mercury, 29.95 inches of mercury. That's the measurement of the atmospheric pressure. And it's saying that this is a automated station called ASOS. This will show 5 observations. And if I click on each of those, it expands them to this.
Oh, okay.
So anyway, when I expand each of these by clicking on the dots or the little triangle right there, it opens them up to the last 5 observations. And if the weather's really bad, those could be in the past hour because the observer has to go outside and take an observation every time the weather changes significantly. Like if rain starts, rain stops. So this is showing an observation at 22:53 Zulu, always in Zulu, which is UTC, which is London time.
Yep.
All times from all observations are at that time, and the standard time of observation is about 5 minutes to the hour. Then you see this case 22:53. But if you see one, here's a 21:53, there's a 20:53, there's a 19:53, and a 18:53. These were all standard 5 minutes to the hour observations when everybody has to take them.
Okay, so they're letting off balloons at these times? Is that what they're doing?
No, these are the weather observer going and measuring with all the instruments, walking outside, looking at the clouds.
Oh, okay. All right. It's like a visual
You go
thing.
to
Okay.
each of the instruments that you have and you put it on your form or plug it into your computer and hit send. It goes out to the
Right.
world.
Okay.
So, so that's the METAR code, which is the acronym. I think I probably didn't say it earlier. I'm not going to go back.
I can put it up on the screen and edit. It's all right.
Yeah, that's cool. So then you have what they call the TAF. This is the forecast. So they're telling you this was the forecast issued at that time, the 16th at 17:27 Zulu, and they're saying the winds are going to be from the northwest at 10 knots, a few clouds at 16,000, and then from 2300 Zulu, 5 hours later, your winds are going to be about that, and you're going to be 6 miles in statute miles and scattered at 10,000 feet. So they're giving you the same code using the METAR code, telling you what they expect the winds and clouds and visibilities to be. Go to the next page. There we go. There's what I was referring to. I should have had that slide first. METAR,
okay.
Meteorological Aerodrome Report, and TAF, Terminal Aerodrome Forecast. So it's a report established for the 5-mile radius around an airport. Each TAF is valid for a 24-hour time period, updated 4 times a day at those 0Z, 6Z, 12Z, and 18Z.
Right.
They like doing the big things in 6 hours, and then the radiosondes are every 12 hours.
Yep, and that's all around the world. They do that.
Yes.
At the same time.
Correct.
UTC.
And the same time being 5 minutes before the hour, and then you have your special observations in between, like if rain starts at X time 20 minutes after or whatever it is, then that becomes a special observation beyond the normal that they have to do.
Sort of fills in the gaps between the 6 hours. Yep. Got it.
Back when I was in San Diego years ago, I had to do the night shift out at San Clemente Island, and I would set an alarm every hour and sleep my way through the night because it was so boring weather. Go outside, clear in 25 miles, and it would literally take 2 minutes to do the observation, put it on the thing, and call it in. It was boring weather. Shouldn't admit that, but so deciphering. So I'm going to give a couple of references that'll be in the notes at the end of with the video, and it does the deciphering for you. So this is going to be just kind of a very brief look at it to show you how the codes work.
Okay.
And here's some examples. Each of those airports has a call sign, like
those green
EF,
dots. Okay.
HK, or whatever. Each airport has its own unique call sign.
Right. Okay.
And then you put in the time of the observation, in this case, 10th of the month at 1450 Z. And then if it's an automatic station with no people, it'll say auto. And then you have your wind direction and speed, 030, which is northeast at 4 knots. And this is just an example of one of the sites that we use, which is called Aviation Weather Center in the United States. That gives you up to 96 hours of data. So you can sort this in different ways, and you get just sequential observations, and you can see each of these, they do them at 51 minutes after the hour. If you keep on going down that, these were all standard observations at the routine time. And when you look for the important stuff, like here, as a, I used to do the weather for a long time, so I'm zoning in on the stuff that's important really quick. Thunderstorm began at 32 after the hour. Occasional lightning in cloud, southeast to south. Thunderstorm, southeast to south, moving east. Those things really jump out at you when you're somebody that is in weather or a pilot. So now you go into, here's some of the breakdowns of things. So like they're going into what the weather identifiers are. Like if you see DS or DU, it's dust, drizzle is DZ, fog is FG. If you have freezing rain, that's really pertinent because that's super dangerous. So you look for that stuff all the time. Sandstorms, thunderstorms. And then you have modifiers. And if it's a minus, it's light. If it's a plus, it's heavy. Sky conditions. Broken means broken clouds, 5/8 to 7/8 of the skies. That's what broken means. Cumulonimbus. Clear skies. Few clouds, 0/8 to 2/8. OVC means overcast. That means the full sky is covered with that layer of clouds. Everything you see. They do it in eighths. Scattered means 3/8 to 4/8. Broken was again 5/8 to 7/8. If you see the thing TCU, that's towering cumulus. Anyway, without going.
Okay. Question.
Yep.
Why do they measure in eighths? Like,
I don't know.
what does that mean?
Octas. I don't know why.
Okay.
It could be tenths because that's more of a decimal system. I don't know. It seems to me like everybody should be in kilometers and metric myself,
yeah.
but so you can get down to the lower part here where they're talking about encoded groups. If you see a 1 is the preface, that means it's a 6 hourly maximum temperature, and the example would be 10183, which is 18.3 Celsius. Anyway, I'm not going to go deep into the weeds here. If anybody wants to break that down, you can just have the manual handy and do it yourself as you're going.
Yep, just cross-reference. No worries.
I'll give you the references and you don't have to memorize this stuff. So, weather maps. They are actually plotted by the computers, and this is what we did by hand years ago. Uphill against the wind, every day, both directions. You didn't get my stupid joke there.
No, I didn't. Sorry.
We used to walk 5 miles both directions.
Okay. Yeah.
We had to hand plot these. That would take you hours, it seems like. And each of these shows
I'm telling you, Sonny Jim, you don't know how good you've got it.
Okay, so this shows the station plots, and then the analyst would come through and put the H for the high pressure center and the low for the low pressure center. And the front types, that's a stationary front, and that's a cold front, and that's a cold front, and there's a low and another cold front. So you analyze these for where the weather is, and the weather is going to be clustered along the fronts. And so a station plot shows the different elements that are measured on that plot. That's how it displays it and where they are located. For instance, temperature is always upper left, dew point is lower left, pressure's upper right. The pressure trend of the last 3 hours, the sky cover is indicated by whether that's, you can see right here, no clouds. 1/10 is a single line. Anyway, those plots are the way we used to do it, and the computers do it now. It's not done by people anymore. Wind speeds. If you have a solid barb, that's 10 knots. If you have a little half a barb, that's 5 knots. That would be 20. That's 25. And if you have a solid barb, it's 50. The fronts are indicated by these colored symbols right here. High pressure centers are H's. Low pressure centers are L's. The clouds, there are 27 cloud types. Basically, that's the main types of clouds: cirrus and altostratus and altocumulus and fair weather cumulus and cumulonimbus. Go back to clouds episode number 4, and that talks about all the types of clouds, and they all have their little symbols. If you have rain, light rain is a single dot, moderate rain is 2, heavy rain is 3 dots, snow the same thing, but with a snow looking thing. Drizzle is a comma. Anyway, this breaks it all down. Haze is indicated by like an infinity symbol. Smoke, dust and sand. Fog is dashes, three of them, 3 or 2, just like horizontal lines. So I'm getting into the weeds. That's your surface plots on those weather maps and how to read a weather map like a professional meteorologist. So this is what you'll see on the news. I don't know. I haven't watched
Yeah.
the news forever. They might not. I can't tell you that they put that weather map on there, but here's how you break it down. So there's your maps again. It's showing high pressure over the center of the United States, and high pressures are denoted by a H. You got another one over Idaho, Wyoming. Low pressure centers are with a red L off of the Pacific Northwest, off of Oregon, California coast. There's a red L. You got another one, Cape Hatteras area, a deepening low pressure center as that comes off of the cold land, hits the warm water, and that thing's going to explode. So that's what happens on the east coast of continents. You know, off of Japan is another generating area for low pressure centers because the same thing, warm southerly current out of the south, pushing to the north, just like the Gulf Stream. So you then have your thing showing the types of fronts. Cold fronts are teeth of winter. That's the way I think it. They're blue, cold. Warm fronts are, you know, hot, red. Stationary, they alternate. Occluded front, we're going to go over that a little briefly here.
Good.
Of what those are. Troughs are dashed lines. Ridges are the lines of high pressure. It's when you have, like if I go back again, like this is considered a high pressure ridge right here. This line of high pressure running from up through the Great Lakes down into Texas. That's a high pressure ridge of high pressure. A trough is that dashed brown line, and then you have a cold front, and there you have a warm front. So all these things are indicated on what they look like on this thing right here for the legend. Here we have your cold front. What is a cold front? It's where the cold air is moving towards the warmer air that's ahead of it. And the cold air is denser than warmer air. So it undercuts the warm air, pushes the warm air up, and along that cold surface, you get cloud formation. And that's the warm sector ahead of it, and that the colder air causes it to rise.
Yep.
And
I guess
rising air.
what helped me to remember that is just things like, I mean, it seems pretty obvious, but I'm going to say it, like cold air being more condensed. It's like, well, the most condensed is ice. And then warm air being less condensed, the least condensed is vapor. So obviously that sort of makes sense scientifically. That's just how I remember it.
Good point.
Being the noob that I am.
Nice way to remember it.
Right, good, thank you.
So
I'm not just a pretty avatar.
Cold fronts in the northern hemisphere move from the cold or the poleward side towards the east. So from northwest to southeast. In southern hemisphere, it's from the southwest towards the northeast, because things are backwards between the two hemispheres of the globe. Warm fronts. So this is a case of warm air moving towards retreating cold air, and that gives you an extended zone. That surface right there means you have thin high clouds way out front, and they get progressively lower as you get closer and closer to that frontal surface. So we did that video on contrails, chemtrails.
Yep.
Back in the southwestern U.S., and we did nice progression photos of how those clouds look as they are coming towards you, and you always get the cirrus first, followed by cirrostratus, then the altostratus, and then nimbostratus as you approach the front, and that's where your heavier rain is coming on warm fronts. close to that frontal surface as those clouds lower and thicken.
Okay.
Occluded fronts, there's two types. So in this case, you have, if you went back to the weather map, so you have right here, you have warm air pushing to the north on the east side of the low, and then you have this cold air pushing to the southwest or to the southeast, coming around the cold air from the north is coming around and moving that way. So as this cold front moves faster, it's going to catch that warm front. And when that happens, you get this happening, which is called an occlusion. So the cold front, the coldest air is behind, the cool air is in front, so it pushes underneath the cool air and pushes the warm front up higher in the atmosphere. You won't have a surface warm front that you could see on the weather map. And then you have the other type, which is the cool air is behind and the colder air is in front. The warm front again gets pushed up, and you have that cold surface there, and you have a cold surface there. So at those two cold surfaces, you have the clouds that go with it, because the warm, moist air is condensing because it gets cooled along those two surfaces. So the clouds look a little bit different in these two cases, but just remember that occluded front is where the cold front catches the warm front, which it always does.
Okay.
And like if you go back to that map again, right here off the west coast, that's an occluded front, that purple. So
right
from San Francisco north, it's occluded, which means it has an upper warm front that's been lifted off the ground. Now I need to go into actual products and show you some of the stuff that goes by going.
Some of the apps?
Yes.
The tools?
Okay. So I'm going to give these links for these two places right here. What's the METAR code and how you read it. And this guy does a really nice job and a really simple little one. He talks about the cloud types, the temperatures, the pressures, and he gives good examples on how this all breaks down. That's just a short little article. And then we have this one here, which gets a little more in depth, and it has a lot more, all the abbreviations that they use. And there's a lot of them.
Wow. That's a lot to learn. Yep.
You don't have to learn it though. You just have to have the reference. That's all.
Right. Okay.
That's the nice thing. You're not the weather observer. You're just deciphering what they put.
Right. Okay.
So now let's look at some of the products. So first of all, the United States everybody's got their own language, but we all have this common language, and each government has their own weather service. There's your Australian.
The BOM.
Appropriately named. Yeah, the BOM. Here's AMAT, Spain. I learned about that a little bit, but I can't really use it because I don't have fluent Spanish. So somebody that has Spanish would go to Spain, and that's their meteorological agency.
Yep.
There are many apps, though, and I'm not going to go in to look at every state. There's people from everywhere here. That's just telling you that everybody knows they have their own weather service. So what we're going to focus on are the ones that are across the board, which is Windy and Venture Sky.
They are these weather services that, the weather people generally refer to with their data. They're all generally government services, aren't they?
Yes.
Government funded, government run.
Correct.
Government everything.
Yeah, like here's your National Weather Service, United States. This is the weather map that you can access with that, and that shows all the warnings and stuff and your surface observations. And you can, if you're in the United States, you can, break it down by get rid of the gusts, get rid of the humidity. You could get rid of the radar, and now you have all the warnings with basic observations with hardly anything.
Just and filter, choose your filter.
The nice thing about computers is, my gosh, it's crazy how much you can get right there. It's like get into serious detail, and then just hover over one of them and you have all your data, and click down below, click on the station, and you have 3 days or 7-day histories. It's wonderful. I mean, this is
Yeah.
the National Weather Service right here. Here's a site called Federal Aviation Administration Surface Weather Observation Stations. This is the one that I used for tracking Helene and the observations that were happening when it came in Milton.
That's right. Yep.
So if you just click on this right here, say Florida, and wanted to see, this is where that thing came ashore, Helene, Perry, Foley, and go there, I have 96 hours of data. This is how I assessed what Helene strength was as it hit shore. The record's
Yes,
right there.
that's no small feat to go through 96 hours of data. It takes you hours, doesn't it? Or days, actually, sometimes. Yeah.
It takes time, yeah. So, but you know when it got there, so you're focusing on just a certain section. So
Yeah,
it
except
just
you've got to look at
proves
the
out.
build-up and everything, don't you? Like you've got to look at the days, the build-up, the days before to.
Well, all that was important to me
sense.
there was what were the winds when it came ashore, and it was
Okay.
tropical storm strength. So, you know, this is how you go into that, and you just say, I'm looking at this site. My forecast for Apalachicola was this, and that's what we actually got. They blew it or not. Here's another site. This one's called Weather Spark. This is beautiful. I found this one when I was looking at Valencia, Spain. Enter your spot. Let's just put in, pick a spot, Stella.
Pick a spot, any spot. That one. Brisbane. Let's go with Brisbane. They've been hammered quite a lot lately.
Okay, so you can
that's
go
October
back to
29th. So that's right.
you can go back to 1940. I don't know how accurate it is, or how complete it is. Probably not super complete, but let's say
Probably
you wanted to go
more
back to
accurate
20.
than now.
Yeah, maybe.
Depends how much they've played with it, basically, because we know it happens.
You could go to the month and pick the date and pick any year, and then you could download the stuff. So I mean, this is superb for that. And if you just scroll through it, you could see all these neat graphs they have. Cloud cover in Brisbane on that date. Observe weather in Brisbane. They have codes for everything. You can scroll through it.
Yeah, and you can filter them too by the looks. If you clicked on like freezing rain, it would probably only show you the freezing rain. That's all filter stuff underneath, I think. Is it? Oh, it's just a legend. It's just a legend. Okay.
Yeah.
Fair enough.
Sunrise, sunsets, solar elevation and azimuth in 2017 in Brisbane. Moonrise. Everything is here. This is a beautiful little site, Weather Spark. So let's see. I looked at that one.
Weather Spark.
At this. There's Australia's. There's AMET. There's the buoys. You have buoy networks that you can go into. Let's say out in the middle of the Pacific or the middle of the Atlantic, and look at it and see what it says. Water temperature, details. It's more than 2 hours old.
How much archival value does this offer?
Well, let's see. How far back can you go? Other than in the past day, it's a day's worth of data, it looks like. So probably that's your buoys. So you get X amount of over the ocean stuff right there. And here we have, if you're on a ship, there's a group of people on the ships that do weather observations. This is a training manual for them, and it tells how to decode what they put out. It's going to be the same. I'm not quite sure why it's going to be the same, but
I guess, there's a few sort of nautical terms that are a little bit different, I guess.
I just found this today, so
right. Okay.
I haven't delved into it deeply.
Just another tool on offer.
So now you get to the main tools that we can all use. So you got Venture Sky. What we like about that is it's not giving you the observations or anything like that, but it's giving you where the fronts are. If I want to just click present day forecast, we just had rain right here near Sacramento, and it's 4 p.m. and it's showing there's still some more offshore. And if I want to know what the temperatures are going to be, it'll tell you. You can put in the name of a city, and you can see up here it's 2 degrees up in Wyoming, so it's cold. You can zoom out and go to Australia or somewhere else in the world. You can see it's up in Canada. It looks not so fun.
Yeah, they're having
minus
that
50.
cold.
That's the
Yo.
same. That's the same temperature as it is for the airliners up at 30,000 feet.
Yeah, yeah, it
No,
is.
thank you.
As above, so below. Literally.
No, thank
Wow.
you. So precipitation, actual
Shout out,
radar.
shout out to our Canadian friends.
Yes,
Stay
you guys are
warm if you
tough.
can. Oh my gosh, yeah, you guys are. Yeah,
Way
look,
tougher than me.
Australians and Canadians, we're tough.
You guys have some cold down there too, but you have a heck of a lot of heat, that's for sure.
Minimal cold, but a lot of heat. Yes.
Look at that. There's Australia, 93.
Lovely day.
That's not so terrible. I mean, that happens in California all the time. But
Yeah.
anyway, all
Couldn't
these
be any different.
parameters, you can pick all these parameters and look at anything, and you can go out to 2 weeks. If you look at the chart right there, here's Friday the 3rd. And, you know, for most weather forecasts, don't bother looking out more than a week because it's not going to be perfectly right. Everybody knows that.
It's not going to be perfectly right ever. So it's 2 weeks. Is that for the free version, isn't it?
This is the free version. No, this is premium. I'm not sure what the free. I have premium.
Okay. I think from memory it might be 7 days. I'm not quite sure about that, but
it's enough.
It doesn't cost much either way. Again, no affiliation, but it's sort of worth it, really, isn't it? Because it's not very much. It's about
not much.
$30 or $40 or something a year. It's not much. If you're interested in this stuff. Yeah.
So one of the cool things about this is something called a temperature anomaly. So it's a deviation from a 30-year normal. So like you can see up near Darwin, I think Darwin's up there, right?
Yeah, up. It's a little bit further up, more towards the coast of Northern Territory.
It's up here somewhere. It's not labeling the cities, but
where are we looking right now? In Italy, sort of area?
Or the Mediterranean, yeah. I was saying that Italy might be having something like Spain had, but it's not the case.
Right. Okay. All right.
You just have a big dip in the jet stream, bringing super, super cold air down into North Africa.
This is the jet stream. That's a really amazing view of it. Yeah, right.
So the jet stream is found where the purple turns into blue. That's where the polar jet is. And it goes around and around the world and comes back around again. You got South America's got a cold pool. Sydney area's got a cold pool, -8. But it is summer for you guys, so that's not as cold as it can be. Antarctica, -29 at 18,000 feet.
We're talking Fahrenheit too, by the way, everyone. Fahrenheit.
Yeah, I have this set for Fahrenheit, and you could change that into in the settings.
It's a real shame that they don't allow the display to show both. That would be really handy, Mr. Venture Sky peoples. If you happen to be listening.
We'll send that to the CEO.
Yeah.
Okay, let's switch over to the app of Windy here. And just for the fun of it, look at, you can switch it to weather radar. I mean, we started out with observations today, so let's jump to that. Let's just pick a place up in Wyoming. So you hover, and you can see the weather observation for that place at that time. So there's an interesting remark right there. FZRANO, freezing rain.
Okay. Yeah, because they're having that cold snap at the moment.
Yep. And they're -7 right now.
Freezing rain. Don't they call that snow generally?
Freezing
that right?
rain, no, freezing rain is rain. You're falling through a warm layer. It could have been snow way up. It could melt before it hits the ground, but then it falls into a cold ground layer where the ground is freezing, and then it freezes instantly. So
Ah, okay.
one of the
So
worst things you can have is
Mm.
freezing rain.
that's usually the conditions that are set for all those pile-ups on the roads, isn't it? Where it's like
Yes.
ice on the road. Yeah, right.
Yep.
I don't know how you people survive. Black ice and white ice and all that stuff.
So just look at a couple other places where there are no precip happening. Anyway, if you just keep on going like this, you can expand and see what the observations were at that time. Visibility 10 statute miles, overcast 7,000 feet. I think that means freezing rain sensor not operable. NO, NO, NO. It's not raining there, so freezing sensor, the sensor's not working, and they tell you that in the observation because that's important.
Okay, so what? Sorry, can you be clear on that? So if they're saying that it's not freezing rain, or that they
It's
can't
not.
give you the data on it?
They can't give you the data. The sensor is not working. This is a ASOS. It's an automated station.
Right. Okay.
That auto tells you that in the
Can't beat
line.
humans. Can't beat humans.
And if I clicked it to raw mode, it goes into METAR code, which you don't
Yeah.
have
Okay.
to learn because you can click it in the raw mode as long as you know what broken means. That means 5 to 9/10 or eighths, 5 to 7/8 of the sky. Over half to not completely is what broken means. As long as you
Right.
understand the word broken
Mhm.
from the codes, then you don't need to go through and learn all this code, the METAR code. But that is the commonality that the world has. We share that code for
Right.
weather.
Okay.
Just taking a look at some of the other parameters, we've already established what we set out to do today. So
Okay.
are
Well,
there
that's probably.
any? It was the intro to the weather maps and the
Mhm.
observation network that the world has. That was the intent of this, not to teach you everything there is.
Yeah.
It's too much.
Yeah. It's quite enough for sort of a one batch of brain input.
Yep.
Certainly is for me.
You understand what a
Um,
METAR is. You understand what a terminal air forecast is. If you use windy, you can go anywhere in the world and figure out what the weather is there right now, almost anywhere
yes.
in the world.
You don't have to wait for those lame stream media people to tell you. And I do appreciate that they put in raw mode, non-raw mode as opposed to raw mode, because it's nice to be able to have layman's terms so we don't have to learn all that other stuff. But we can if we want to. Depends how far you want to go into it.
Yep.
But it's all possible and it's all there. That's the whole point of this, is all the information is there. We're just showing you where it is, what it is, how to find it, pretty much. And then the rest is up to you.
Correct.
No excuse to not be informed, basically, is
The
the moral of the
information is
story.
out there. Yeah,
Yeah,
you can go and find the information if you know where to look. That's the important part.
yeah. Preferably not social media for your conclusions on what's going on with the weather.
True, true.
Yeah. All right. Is there anything else you would like to bring forth, or is that complete?
I wanted to show you here that there's a little pressure button right there. It shows the lines of equal pressure, which is how you find the low and the high pressure centers. It gives you circles, and I don't. Let me refresh completely.
Probably the problem.
Try it one more time here. There we
Ah,
go.
there we go. Beautiful. Nothing like a decent refresh.
Yes. So that shows you all the low pressure centers, 992, 985 up over near Hudson Bay. High pressure, 1046. So that's super, super high. Fog has been in the news a lot lately. Let's look at fog.
Okay, let's do that.
So it looks like a whole bunch of Europe,
Toxic.
UK, Ireland, Portugal, Spain, parts of France, Germany, Italy. There's fog everywhere, but it's not everywhere. It's about
Are they purposely only showing it over the land, or is there any, like, do they normally show it over the sea, or is there not fog over the sea?
Well, there
Generally.
would be if there was warm water, cold surface. So you're probably not going to get much because it's warm water. There is no land surface that's colder. So you have to have that warm water going over a colder surface to get fog.
Right.
So
That explains that.
it
Yeah, isn't
happens.
it? It's interesting, isn't it? The way it's.
I'm sure somewhere on here we would find fog at the right time of day, but at the current time, not.
So we're looking at all the white clouds. That's the fog, isn't it?
Yes.
Yeah. Right. Okay.
And you could
So nothing
zoom
much over
through
America at the moment, North America.
tomorrow morning
A bit
at
around
6 a.m.
California.
That's going to be a whole bunch down the center part of the state from Colorado eastward, up in the Washington, eastern Washington area, British Columbia. You got a whole bunch of places there. And as you go through time with the premium method, bad storm there over look at those isobars. It looks like a bullseye. Those winds right there over Nova Scotia, strong. You would not. That's like probably hurricane force winds.
That's Nova Scotia, is it? Okay.
Yep. I think that's Nova Scotia right there. Or is that Nova Scotia?
That's a bit.
This might be Halifax.
Oh, look, you're talking to a geographical retard here, so don't ask
St.
me.
John's.
Yeah, zoom in.
Sydney's right here. I didn't think Sydney was there. I thought it was in Australia.
I have heard there was a Sydney in Canada, yes. Well, I've also seen it in drop-down menus here and there, but
there's Nova Scotia.
There you go. Yep, you were correct. Well done.
So
I would never dispute anyone talking about geography.
There's your winds right there. So one of the cool things about Windy is you can just click on a spot and it'll show you the wind speed. Drag that somewhere else in that purple zone, 40 knots. Windy's wonderful. I like it better than Venture Sky.
Little drop-down menu. Can you just click on that little orange round dot with the arrow on it?
That?
Forecast. Oh, okay. That goes to a forecast, right? I guess.
Forecast for that location.
Oh, there we go. That's right. I love the way this comes up.
Yeah.
It's cool.
These tools are wonderful these days. So explore Windy, look at any of those parameters and a whole bunch of other parameters. And if you want to get to the airports, you got to go to there. If you want to get to Radiosonde data, it's there. And you have all these other parameters that are available to look at all this fun stuff for the
Would you
weather
be
geek.
able to just quickly go to a Radiosonde just to show the people
Sure.
again, just to remind them what it looks like and stuff, how to get there?
Let's look at a nasty place like St. John's right now.
Yep.
So that would be like, here we are. Wow. Windy has been
Appleman chart, yeah?
Windy's been funky lately. They've been really not updating the Radiosonde data quickly. And that's the Radiosonde data for St. John's. And you can see the winds are strong all the way up in the 50 knot range, as those show right there. The nice thing about, one of the things about Windy is it shows you the wind speeds. It shows you, you just bring that cursor up on the line and it shows you all the parameters spelled out.
Yeah.
So minus 46 for the temperature of the air at 27,204 feet. Minus 72 degrees Celsius is the dew point, which is the blue line to the left, 49 knots from the southeast or west, which is almost south. And that's your Radiosonde data that's telling you that there's going to be clouds there at about 18,000 feet. You got clouds down here around 7,000, but that's another class totally. So
yeah, we've sort of gone through that a little bit anyway. So yeah, the closer the lines are together, there's cloud. The further away they are, it's a dry area.
Right.
Basically. Yeah. Well, okay. That's fairly comprehensive. Rather.
We accomplished what I think we were supposed to do today, which was to show the Weather Observation Network, and we just had a little bit of extra stuff there.
Yep. Well done. All right. Well,
Okay.
I'm going to bring us back to the screen where it's just you and me, because I know you can't see us. And thank you for that.
You're very
Bringing
welcome.
us up to speed yet again so that there's a little bit more understanding, because like it looks like a lot, and I mean I'll admit it, it's taken me ages to get some of the really basic stuff into my head, but once you do and you sort of the picture starts, it's like a little blooming flower. The picture starts to open up and you start to get a little bit more, just like anything, just like learning anything. Just learn a few terms, see things enough, and also just going on to Windy or Ventusky, Venture Sky, however you say it, and just playing, just spending time playing, and that opens up a whole bunch of stuff as well. It's like, oh, okay, it all starts to come together, you know. But, you know, it's finding the time to do these things is the hardest part, really, with all the busy life and everything. So hopefully we have helped a few people with some clarity.
The information's out there for anybody that wants to learn it, and can always come and ask us. Send us questions to the email if you have questions.
Yes, just along the bottom of the screen there, you will see that there is an email. If you do have some valid weather questions and itching to know the answer, please send them on to weather@stellaq.com.au, and Jeff will deal with most of those things in time. So, yes, encourage you to do that, or just have a play. Have a play and it'll all come together eventually. Eyes on the skies, but keep your feet on the ground. Thank you very much, Jeff, again, for showing us more of your wise knowledge and sharing with us. And thank you, everybody. If anyone's still here, thank you for sticking around and giving us your ears and eyes. And we do hope that that has been of some value to you. And we look forward to bringing you some more weather or not information in the near future. Thanks again, and take care, everyone. Bye for now. And here we go. We are recording. And hello, Jeff. How are you doing? No,
hello,
hang on. Start again. How are you doing? Where'd that come from? Hang on a minute. Right. Rewind. Hello, Jeff. Good to see you again.
Hello, Stella. And
okay, rewind. Let's start again. All right, here we go.